Hello and welcome. My name is Senthil Arumugam. This is the presentation for the final project for the Harvard course E63 Big Data Analytics. My final project topic is studying a tool called Apache Kafka, which is a scalable, fault-tolerant messaging platform for use in big data. So this is the one-page project summary, and I'm going to walk you through what is Kafka, why we need it, and a simple use case demonstrating its use in stream processing. So why we need Kafka? Because often in the world of big data, data is consistently produced and consumed in a variety of ways by various kinds of applications. Data transport between applications is becoming more and more complex, and Kafka offers a fast, scalable, durable solution to this problem. Kafka is basically a publish-subscribe messaging rethought as a distributed commit log. You could think of commit log as the log that is normally used by databases to keep track of the transactions that's performed. So it follows that same logic, except that all the other traditional message brokers does a lot of other stuff, but Kafka simplifies all of it by pushing all those responsibilities to the consumer side. So we'll be looking at what Kafka is, how to install it, how to configure it, and the big data that is sourced for this project, which is using Twitter streaming API, and the project is run using my Apple MacBook with a 4 GB RAM. And the software that is used are basically CentOS 6.4 Cloud Era VM and Apache Kafka version 0.8.2.1, which is the latest version, and a version of Zookeeper that comes bundled with Kafka. So in order to talk to the Kafka, so you need some sort of client. I'm using a Python client called Kafka Python. And for data sourcing, to talk to the Twitter API, I'm using a library called TweePy. So let's go and talk about what Kafka is. So like I just mentioned, Kafka is basically a publisher subscriber or a message broker for stream processing in a publisher subscriber architecture in a distributed environment. So why is it successful? Because it can handle high throughput and low latency messaging. And so who founded Kafka? Kafka was founded in or created by LinkedIn around 2008, and it was made open source in 2011, and it is now an Apache project. So the founders of Kafka actually spun off from LinkedIn and started a company called Confluent, who is now doing most of the development of Kafka. So this is the basic overview of a message broker. So you have a couple of producers publishing messages, and these producers could be any sort of data source. It can be a stream, it can be a file, it can be another system. And on the other end, you have the list of consumers, which is consuming this data. When the producers produce the messages, basically the messages go to what they call a topic. A topic could be any sort of a category. For this project, my categories are like music and movies and sports and news. So you have messages coming from the producer, published from the producer, going to these topics, and you have the consumers consuming messages from these topics. So each topic is basically a commit log written in the disk, and this whole thing is managed in the Kafka cluster. And because this is a tool for distributed environment, you can have multiple brokers that's handling all these messages. So a topic, this is just the list of definitions of the terms that I just talked about. So a topic, like I said, is basically a stream of data being written in disk, and the messages are written sequentially. A topic could have one partition or many partition for load balancing, and because it's writing to the same disk partition every time, even though it's writing to the disk, it still is fast and has very low latency. So the only thing that Kafka manages in the commit log is what you call an offset, which is basically the reference point um, to know which message has been consumed by the consumer. So Kafka doesn't take a lot of responsibility on its own. The responsibility is mostly on the consumer side to consume those messages. So there are several use cases for Kafka, like in messaging and stream processing, website activity tracking, and log aggregation, and so on. So for this project, I'm going to be using Kafka for stream processing. So to talk to Kafka, you have the native Java and Scala clients, but for my project demo, I'm using Python. So because it's stream processing, of course, the obvious choice is to use Twitter streaming API, and that's what I'm using. So to talk to the Twitter streaming API, I'm using a Python Twitter client called GPy. So the data that I'm using for this project is basically all the live tweets that are streamed, which has a reference to the top 100 most followed Twitter accounts. To give you a sense of data, that's about 1 GB of data when written to a file in an hour. So I have two producer scripts producing the Twitter streams, the live Twitter streams. I have two to split the 100 Twitter accounts into 50 and 50. So this is just to give you a sense of having multiple producers, but you could have any number of producers. And the producers publish these messages, categorizes them, and publish these messages into one of these topics. And all the messages are handled by Kafka running 3 brokers. And on the consumer side, I have 3 consumer scripts reading the music topic, the social topic, and the politics topic. And this is a cluster, so this cluster is being managed by this tool called Zookeeper, which is used for fail or failover. So when one node goes down, you can switch over to the other one. So this is just a sample script showing the producer script and the output, and the same thing with consumers. So I'll go back and show you the demo of how to install, configure, and run these scripts.